so here is number 10. Sorry, I had corrected it because before I had typed it, I had copied it over incorrectly. So I'm gonna do it over and show you how it's done. Okay, so you have these two functions, which you don't want to get y by itself because it's easy enough to do. So I'd have y equal to x cubed minus 4x, and y is equal to 2x minus 1. And I'm going to call that f1 of x. I'm going to call this f2 of x in my calculator and also here, just so it makes it a little easier when I go for the pictures of it. So this is second clear. Let me go to my graph. I go to apps. I can go into the regular function. I type them both in. I plot them, and here they have two areas. Two areas that you have to find because it's bounded by the whole function. So this is the only time they're going to intersect. So you find the area of this one, area of that one, and you add them together. Okay, so how is this going to play out? So I am going to make a sketch of these two. And that's going to look something like this. Let me make it pretty here. Okay, so I have this, and I have one of them is like pretty much like this, and the other one is pretty much something like that. Okay, and these are my areas, and I know that there's an intersection here, A, an intersection somewhere around here, B, and somewhere around here, C. Okay, I am going to find A, B, and C. A, B, and C, and I'm going to label them over here as to what they are. So, and this I can do on the AP as well. And I'm going to store them in my calculator. So what I'm going to be showing you is like some calculator techniques, which is really much easier to do on video than in class anyway. So it's kind of a cool thing. Okay, so I go to here. So I'm going to go here, menu, and I'm going to do function, intersection. Okay, I found the intersection. I write it down. I go negative, I picked this one because that's the closer to that one, negative 2.5289, right? And I want to store that. So what I'm going to do is I'm just going to, for that moment, I'm just going to go to the home screen, just the regular home screen. And see how it says stow? I'm just going to hit stow. Actually, let me see if it does it. Stow. I wonder if I just put it in here and do alpha A, if it stores that value. Yes, it does. Okay, so that's good. So I have that value. Then for some reason I feel like I had to put an X first, but let's see how it goes with the next one. So I go back to the next one. I go to plot. I touch near where that intersection is, and I go menu, function, intersection. Okay, I have that intersection. I write it down. So I'm going to go over here. I'm going to write down that intersection, 0.16745. And I'm going to go to my main screen and press stow. I wonder if I do alpha, and I press alpha B. I wonder if it stores this one or the last one. No, I don't want that one. So yeah, delete that one. I don't want that one. So I want the X value we just had. This was from before. So I'm just going to go to X because I just found an X value from the calculator. Hit enter. Gives me the one I want. That's the one I want, right? So I go, okay, now I want to store that value. That's what I thought. Okay, so I store that as alpha B. Enter. And now that's B. Okay, so that's good. So now I'm going to go to the next one. I'm going to go to, sorry, I'm a little distracted. There's a lot of people just texting me. It's really annoying. Okay, so I'm going to go to plot again here. There we go. Menu, function, intersection. Okay. And I have that value. and I write that in, 2.36147. And then of course I got to go to the main screen. I hit X again. I go, yes, I just got an X value. Enter, you can see it, make sure, and they say, yes, I want to store that X value and I want to store it in alpha C. Enter. So now A, B, and C are stored, and so when you go to your calculation, but you can't just calculate it without writing it. All the points are right here, so you're going to write, this is going to be the integral from A to B. The top function is the curvy function. That is f of 1, right? So that's f1 of x minus f2 of x dx, of course. And then that's going to be, I'll just put it underneath so it has room, plus then b to c, and this is f2 of x minus f1 of x, right? And that is because the top function for this area is the linear part, okay? So that's the linear part. So now I'm just going to calculate these two things and then add them up. I think it's good to show it broken up just because, and that just makes it better. So I'm going to go to here. It's better if I look at it here. And then I'm just going to do alpha A to alpha B, and then I'm going to do alpha, I pressed alpha again, f1 of x minus alpha f2 of x dx, enter, and I like to write what that approximately is, 11.5733, okay, and then I do this again, enter, I'm going to change everything. This is going to be a 1, this is going to be a 2, and then this is going to be alpha C, and this is going to be alpha B. Okay, and then that number is 6.677. I add these two, and when I add them, I just go, you know, plus, I take that one, enter, sure, and I get 18.25058, or in other words, 18.251. Okay, so that's that.